Hi, this is Mr. McConley. Mr. McConley, and this is BKW General Physics class. Last time we talked about current in a series circuit, and today we're going to talk about current, or what we call the flow rate, in a series as compared to a parallel circuit. Let's go check it out. So, what you can see, almost, I have to adjust a few things here. That's better. What you're going to be able to see here is that I have my original series circuit from the last video that I was making, and the electricity is flowing from the DC power supply. It's flowing through the switch, which can control the on-off of the light bulbs, through the first light bulb, through the second light bulb. And what I showed you last time as a quick recap is that we could use this thing called an ammeter to check the flow of electrons, which is measured in amperage, amps, and or coulombs per second. It's how much charge is flowing. And I reset it a little bit so the numbers were a little easier to remember, or rounded. So I have the same setup, and right now it's reading 200 milliamps, or 0.2 amps. Remember that number, 0.2 amps. That's the flow of the electrons right now. But what if I made this into a parallel circuit? So here's what I'd have to do. The electricity would come up on this wire, and when it got here, it needs to have a choice. The choice would be the electricity could flow up to this point and go through the first light bulb, continue through the ammeter, and then skip the second light bulb. So right now, if I turn this on, it's only going to light the first light bulb because see, it's skipping the second light bulb. Or the other choice to make it parallel, or make it a parallel circuit, is to have it come up, and when it gets to that first light bulb, have it skip the first light bulb but go through the second light bulb. So now both the bulbs are lit. Great. How do we check if this is really a parallel circuit? So if I take this light bulb here and I unscrew this light bulb, that light bulb will stay on. Why? Because the electricity can go through this light bulb or through that light bulb, independent of one another. And since it's independent of one another, that makes it a parallel circuit. So we can check it with this one too. If I unscrew this, that one still stays on. Great, I must have wired it right. Well, now remember, I still have my ammeter, and my ammeter is checking how much light bulb goes through, how much electricity, how much current, how much amperage goes through this light bulb. So right now I'm checking this light bulb, and it's reading 0.22 amps. So that's a little bit more than the series circuit. That's interesting. Well, let's switch it around. So we got 0.22. Let's turn that off for a minute, and let's switch it. Let's have the ammeter now measure the electricity that is traveling through this light bulb. So we're going to have the electricity that comes up and goes through this light bulb. We're still going to have the other one so it works. We're just not going to be measuring it right now. So let's check if we, first of all, wired it right. We disconnect that one, the other light bulb stays on. We disconnect this one, that light bulb stays on. Okay, good, it's wired right. Now let's see what we have for electricity flow. So right now, we have the electricity coming up, going this way, going through that light bulb, and it's reading 0.26. Wow, that's interesting. So remember, with the series circuit, it was 0.2 amps, or coulombs per second, flowing in a circular pattern. And in this situation, through the one branch, through this branch here, we have 0.26, and through this branch up here, we have 0.22. So we have more current in each of the branches than we had the total with the series. Well, why is that working? Well, let me explain it this way. If we're going to use an analogy of driving on two different highways. If there were two highways that could get you to the same point, we have I-88 and Route 20. Either one of those highways will reach or get us to the same point in the end. So if you have 100 cars, 100 vehicles that are trying to travel, if all of the vehicles are forced to travel on one highway, that highway is going to be congested and it won't flow very good. Like, people will have to slow down and brake because there's too many cars and they're all kind of in each other's way. But if you allow half the cars to go one way and half the cars to go the other way, both highways will flow more efficiently, and therefore you'll get a better flow rate. It's the same with electricity. Electricity has two choices in this setup, this parallel setup. It can go this way or this way, and because of that, both of those paths will have a higher current or higher electrical flow. It flows smoother on each of those. So what we've learned is that in a parallel circuit, as you create more branches, it will allow the electricity to actually flow better. So let's do one more thing. Let's check one more thing here. What if we disconnect this? Okay. I'm going to go get one more wire. Now, does it matter that it's a black or a red wire? Not at all. It's just the one I grabbed. So I'm going to get this parallel circuit working again. Okay. It's a parallel circuit. I don't have the meter hooked up yet. Now, what I'm wondering is how much electricity, this is the parallel part with two branches, but how much electricity is flowing through this part? The part that is the series part, the part that comes from the meter and travels to the light bulbs. So I'm going to hook up my meter here, and this is now measuring the electricity that comes from the power supply and supplies the two parallel branches. So interestingly enough, it almost reads 500 milliamps, almost 0.5, a little under. What's happening here is if you take the electricity that's going in the series part, it will split between the two paths. So like I was saying with the car analogy, if you had 100 cars, then 50 could go each direction. The 50 on this direction, the 50 on this direction would add up to the 100. It works out the same way. Our numbers are a little less smooth, but we have 0.22 and 0.26. So when we add those together, we should get like 0.48 or 0.49 in change, depending how we round them. And that's what we're getting. So we're showing that electrical flow, all the electricity goes through the series part, and then it can split and travel more efficiently. So simply by rewiring, we've allowed for a higher flow rate. So for today, we've learned about series as compared to parallel flow rates, which is electrical current. This is Mr. McConley, BKW General Physics.